right, good morning, everyone. Good morning. Let me just disable the waiting room. All right. Can you hear me?
Yes, sir.
All right.
Yes, sir.
So, how's everyone doing? Quickly, how's everyone doing? Good. Tired. All right. Let me see if I can jog your memory to help you get some energy. Can you remember what commutative law is? What did you say yesterday about commutative law? All right. Commutative law. Anyone?
Morning, sir.
Good morning. So look back in your notes. Commutative law. We looked on it yesterday. I'm just asking, what do you remember about yesterday's class about commutative law? First of all, we know it's a law, so it's an order of operation, right? And I gave the example, like for example, what if 3 persons arrived in the Zoom call and then another 2 persons arrived, right? Commutative law is telling us that even if 2 persons arrived first instead of 3, and then another 3 person arrived, we would have gotten the same answer. Because 3 plus 2 is 5, and 2 plus 3 is 5. So that was the commutative.
Question, sir.
Huh?
Sir, are we using bad maths today?
Yeah, we're going to be continuing on bad maths after we finish the laws today. All right?
I have a question. Aside bad maths is very easy, right, sir?
Right. It's very easy, but I want you to understand the laws first. So the commutative law, as I was asking a while ago, no one really replied. So I just want to make sure you understand it. So everyone understand what the addition aspect of commutative law is? Where no matter the order of how you add the numbers, you'll always get the same, no matter how you add it. Understand?
Yes, sir.
Sure. All right. Now, I want someone to understand, why can't we use subtraction in commutative law? So,
Sir, I want to go.
All right, go.
Yes, sir, because you can't take a bigger number for a smaller number, sir. For example, let's say David has 12 cookies and he wants to give 40 to Nicholas. He can't do that.
Right, so let's say David has 12 cookies, 12, and he minus 4 to give to someone. We're saying, all right, let's just use the example. So David had 12 and he gave away 4 to Nicholas, right? So what if now Nicholas had 4, and he's trying to give back 12 to Nicholas, to David?
Yeah, -8 is the answer.
Right. So in essence, what he's saying is that 12 minus 4 is 8 and -8. Are these the same answer? No. Right. So that's why subtraction cannot be used in the commutative law.
Yes, sir. Can you send me the link, sir, to the notes, sir, for today?
All right, sure. Copy
Sir,
your.
I cannot access to the notes, sir, so that's it.
Right.
Sir, I missed it. Sir, I got disconnected.
There you go. Let's take a quick note of who was here. So did everyone get to do their exam? Yes, sir, no, sir?
I'm almost finished with it.
You're almost finished with it. It's supposed to be submitted already. All right. I'll have to speak to
I'll
who.
submit it today.
All right, please do. Please do. All right. So subtraction cannot be used in a commutative law because you cannot have 2 numbers, subtract them, and get the same based on the positions. All right, very important. So now the next aspect, right, of commutative law is multiplication. So let's write this. Multiply 2 numbers. So under the multiplication aspect, so this was addition. This was addition. And now we're going into multiplication. All right. Now this is saying multiply 2 numbers, exchange the position, exchange the positions and the product remains the same. Does everyone know what the product is in mathematics?
Sir, the answer when you multiply.
Yeah, correct. No, there's another part of our multiplication I want you to understand. Something called factors. Right?
Oh.
Right. So when you have two numbers that multiply to give you another number, those two numbers are called factors. Let's write that.
Sir, can I share an example, sir?
Give me an example.
Let's say, for example, you want to find all of the factors of 50. You know that 1 times 50 is going to multiply to give you 50.
Right.
2 times 25 will also work as well, and 5 times 10. So you can say factors of 50 are 1, 2, 5, 10, 25, and 50.
Right, exactly. So let's write the definition of factors quickly. Factors are numbers that multiply to give a product. And products are the answers from multiplication. Okay, good. So let's give a quick example. As Khalil was saying, let's give an example quickly. So we're looking at the commutative law of multiplication. So the general form, as I said yesterday, was general form is A times B gives us B times A. We went through this yesterday. I was doing a general review. Right? So if we say 4 times 2, same thing as 2 times 4. Right? Both of them is 8 is equal to 8. So let's write the heading commutative law of multiplication, commutative law of addition, right? And this was why subtraction cannot work. Why subtraction is not commutative. Everybody on the same page?
Yes, sir.
All right. Now we're going to go into another one before we move on. All right. I'm going to give you now one example. You're going to fill in the blanks for me. Okay. Give me the commutative law of multiplication for these two numbers. 34 multiplied by 71. What will be... Anyone? 34 multiplied by 71. Give me the... Using the commutative law of multiplication, rearrange that for me.
So what are the numbers again?
34 multiplied by 71. So rearrange it using the commutative law of multiplication.
71.
Can you repeat?
The answer be 71 times 34.
Right. Same as... All right, so another one. Square times triangle. Give me the commutative law of it.
Triangle times square.
There you go. Okay, good. It looks very simple now, but trust me, when I go down further, you'll understand now how it is. So what I'll be doing is I'm going to give you now a true or false exercise to do as homework. Right, so let me write that down. So at the end of the class, I'm going to give you a true or false exercise. Right, put it in bold. True or false. So that's going to be the first test I used to see how well you understand commutative law. But now we're going to move on to the next topic underneath, which is associative law.
Excuse me, sir, do you know that the actual answer for 71 times 34 would be 2,411, sir?
Nice. You calculated it. Good job. Nice.
I calculated it in my head, sir. Once, and sir, I got it because I said 34 times 7 is 238. Then put down a 0, sir.
Good. Right.
Then plus it by the 34, and that's how I got my answer, sir.
All right, good. Thank you. So, can we move on to associative law now, everyone? Does everyone understand commutative law?
Yes, sir.
All right.
Yes, sir.
Close it up. Let's go into associative law now. So, what is the definition The definitions, right? So what is a definition? Right? This is how we take notes. We go linearly. So we explain every step. So the definition essentially is that you're grouping numbers, highlight grouping numbers when adding or multiplying, because it does not change their sum. And what do we say sum was? Sum was for, if you're finding the sum of two numbers, what are you doing?
Adding them.
Right. If you're finding the product of two numbers, what are you doing?
Multiplying.
Right. So the definition is simply saying, using associative law, you're grouping numbers when you're adding or multiplying them. Right? Okay. One moment. Let me just go here for you. So everyone take the definition down. All right. I'll give you a moment. All right. So I'm gonna give you I'm gonna do two examples, right, to show you how you could associatively add and multiply two numbers. Right? So let's say I have three numbers, 70, 50, and 30. So using associative law, three numbers, 70, 50, and 30. And they're adding. Right? Remember, this is on page 9 in your book too, but I'm just going through and giving a summary. So we're trying to add these three numbers, but can I calculate? Well, all right. Can you mentally add three numbers one time? No. It's if you can, you're very talented. But in your mind, you cannot add 4 plus 8 plus 500 at the same time. You have to do 2 and then you go to the next. So in associative law, you essentially group any two numbers together. So let's say we group 70, and we can choose any of the other numbers like 50, right? We add that using BODMAS, right? And then we use the next one now, 30. So let's look at this. 70 plus 50. Anyone? 70 plus 50? 70 plus
120, sir.
120.
There you go, 120. And then now we're going to add that to 30. And let's see what we get. 30. We get 150.
150.
So this was the first method of grouping numbers. Let's see if we change it to 70 plus 30. So we'll group 70 plus 30 now instead of 70 plus 50, and then add 50 outside, and let's see what we get. Quickly calculate it. That's 70 plus 30, 100 plus 50, that's 150. Everybody see what I got that? 70 plus 30, 100, and then 100 plus 50, 150. So commutative law is saying that the answer does not change, no matter how the grouping is, when you're adding. So this is addition. So let me give you an example for you to do. Example. All right. 100, 150, and 850. So you're gonna do this example for me. 100, 850, and 150. Using the associative rule, right? Combine these numbers in 3 different ways, and you're supposed to get the same answer. But 2 different ways, 2 different ways. And tell me what the answer you get for both methods is.
So do we just say it, or do we?
Yeah, just say it.
out?
Just say it.
Okay.
Just say it.
So, 850 plus 150 plus 100, or 100 plus 150 plus 850.
Right. So you just group. So we use the BODMAS, right, to work out the brackets first. So by working out the brackets first, than the addition of the third term. So let's look at the steps now. So that was the example. Go to a quick step, the steps. So if you're working with three numbers, essentially the first step is to add the first two numbers. Step 1, add the first two numbers. Right? Then step 2, using that result, add to third number. Everybody understand? All right, so those are the steps. Add the first two number using brackets. Not bad. Okay. All right. So we can come up with a general form. So the general form to describe any associative law, the general form, let's just use A, B, and C instead of numbers. We're going to say A plus B plus C, right, is equal to C plus, is equal to A plus B plus C. So look at this for me. A is not in the bracket, but based on the associative rule, because they still share B in common, they will still get the same answer. Right? It's only when one of these is changed to D, for example, where the associative rule not hold. So this is a general form of the associative law. All right. There we go. Okay. Everybody take that down? Okay, let me close these up. All right. So we're going through very quickly, right? And what I'll be doing, I'm going to give you an exercise as well. So far we're going through 2 exercises for you to do after class. It's going to be a follow-up exercise. It's going to be in the portal directly after class. All right, so you have 2 exercises to do to see how well you understand it. And let's just quickly move on. So let me give you a quick example. Ready for me? It's in the book, page 10. So we're going to say, Danny, father, right, bought 3 boxes of juice. Right? There are 25 cans per box. So let me just quickly put real world scenario. Real world scenario. So Danny's father bought 3 boxes of juice. There are 25 cans per box, and each can costs $4. Each can costs $4. Right? How much did his father pay in total? In total, using associative law. Okay, let's break this question down. Right? If he bought 3, so let's write down what we know. We know we have 3, right? And we know that each box has 25 in there. So what was the word that I said last class that identifies what operation? So if we have 25 of each box, how would you find the total amount of cans?
You multiply?
Right. So the word of is multiplication. So we'd say 3 times 25. There we go. So 3 times 25. But we're not finished because that is just how much cans we have, right? We haven't found out what's the cost. So if even after we get this value, 3 times 25, right? That's the total amount of cans, but it's asking us how much did the thing cost. So what was the price of each can?
$4.
Right. So if you have the total amount of cans, how would you calculate the price for each can? So you would say 75
Times 4.
times 4. 75 times 4. That will give us $300, right? And let me ask you a question. So what we did was to have 3 times 25, then that times 7, right? So we had 3 times 25 in a bracket, then that multiplied 7. But we could inadvertently, that's a big word, but we could have exchanged the 3 and the 7 and still get the same answer. Would you believe me? So that's the associative law. We could just switch any position because they're the same 3 values using the same operation, right? So that's the associative law of multiplication. Let's write that. Associative law of multiplication. Right? The general form. So we just did a question for it, but let's write the general form. Is simply A bracket B times C. Because remember, what did I say about the bracket? It multiplies the, wait, let me just do it right now. So there we go. So the invisibleness of the bracket is essentially saying you're multiplying, right? So no matter what the answer here is, you're just going to multiply it by A. Understand? Or we could have said, or C bracket A times B. So we could switch positions. Switching the positions of terms does not affect the answer. All right. Write that right there. Multiplication. All right. That's pretty much. Right. Use me your mic. Use me your mic. Okay. Okay. Let me give you another example. Is everyone finished with the notes? All right.
Sorry, frozen? Oh, never mind.
No, I'm not frozen. I'm just waiting until you finish with the notes. Right. Okay. So let's continue. So, what are the 2 rules, or what are the 2 aspects? So, in summary, what?
Yes, sir.
Yeah.
Sir, you made a mistake, sir. You should have put 4 instead of 7, sir.
Where?
There, sir, because it costs $4, sir.
Right here?
Right there, sir. But 3 times 35 and 7, sir. It should be a 4, sir.
My bad.
Because it costs $4.
Right. Should be a 4. But I calculated using a 4. I don't know why I put 7 there. My bad. Okay. So it's still 300. Okay. So in summary, what are the 2 aspects under the associative law? Let me give you the first one. It was addition. What was the second one? So the first one was addition.
Multiplication.
Right. But I want you to help me now. What is the general form for addition? Go back in your notes. Tell me the general form using A, B, and C.
As just like you put 2 numbers in brackets, sir, to answer, and then put a bracket outside for it to answer. As soon as you finish add those 2 numbers, sir, then you add the numbers which you get in the brackets and to the number outside, and that's how you get your answer, sir.
So you said add 2 numbers, A and B, A plus B, right?
Yes, sir.
Then add another number outside of the bracket.
Plus C equals 50.
Right? And now, how would you rewrite this using the associative law? Because we said that some terms could be switched. So switch two terms for me. Switch C and A and tell me what you got.
C.
So you would
C
say
plus A plus B.
So you say C plus A plus B. That's the general form. Now let's go to multiplication to summarize. Multiplication. I want ask zero to help me with this one. Right. So we have three terms, A, B, and C. Using the multiplication rule, right? Tell me what the general form would be. So you'd say you have two numbers. So choose two numbers to multiply from A, B, and C. So you could say A times, you go.
A times B.
Right.
C.
C where? Here?
C outside the bracket.
Oh, okay. Outside the bracket. Okay. Then now, how could you rewrite this using the associative law? So you can remember, rewriting it is essentially switching some terms. So you could
C times B.
C times B.
And then outside the bracket,
A. There you go. And that's the summary of everything. So remember, I'm gonna give you a follow-up exercise and put it down here. It's gonna be on the portal as soon as we finish class. That's really gonna check to see how well you guys understand the topic. Go down here. But what I want to do now with the remaining of the time, because we just finished associative and commutative, I want to go to the last law, which is distributive. Right? So head up distributive law for me. So that was commutative and associative. If you want any revision, you can go to this that I prepared for you, or just go to page 10 in the book too. All right? Let's go to the distributive.
So I have a question about this website. Like, how do you get to it? Like by yourself, how do you get to it?
Okay, so let me show you. So you copy the URL I sent in the Zoom chat, right? When you click on it, if you're on a phone device, it's gonna be a little bit different. But essentially, when you click on the link, I'm gonna send you the link again. When you click on the link, you're gonna see a little symbol pop up in the middle, right? Like it's a spinning wheel.
Yes, sir.
Right. Now, when that wheel is finished spinning, it's gonna now take you to the page that has all the notes, right? And to access each note, it should look like this. So to access each note, it's gonna look like this. The previous class was 27th of October, right? So when you want to go back in time, like you're time traveling, you just go to the little bullet point right here. You see a little triangle, you click on it. Click on that, take it to the laws of operations, right? And then you can go and take the notes for each operation that we talked about yesterday.
Okay, sir, but like, how about the ones like from September or something like that? Can we go to those?
Right.
Or are those not there anymore?
So those are on a different site, and I'm currently like redesigning it because I want to put everything in one space. So like as soon as Saturday, you're gonna see all the dates lined out right here.
Okay, thank you, sir.
Yeah. Okay, let's continue quickly. So let's go back, and we're gonna talk about the distributive law. So we did the commutative. We're gonna do one more distributive law, and we did touch this previously. Distributive law.
Sir.
And
sir, I found the definition, sir.
Right. Let me hear your definition.
Sir, the distributive law for an arithmetic operation deals with the multiplication of numbers in brackets.
Right. Okay. So now we're seeing the BODMAS rule coming out, because he said we have things coming out with multiplication and brackets. All right. So we're using these two things to distribute a value. So let's write a definition as he said. So we're gonna say the distributive law, right, deals with distributing a number, it's in the name, throughout a bracket, right, over other operations. Now I'm gonna ask a very redundant question, but why do we take precedence or take importance to brackets than other operations? What rule is there that tells us that we have to do brackets first?
So that we don't get mixed up with the numbers.
Right, but what rule is there? So what's the name of the rule that tell you that you have to do that to not get confused?
BODMAS?
Oh, okay, cool. You found it. Good. So BODMAS rule. BODMAS rule. This is the BODMAS rule. Let's go back and remind ourselves of the acronym. What does the B stand for?
Brackets.
Right, brackets. What does the O stand for?
Over.
Right. What does the D stand for?
Division.
Division. Okay. What does the M stand for? Multiplication. All right. What does the A stand for? Addition and subtraction.
Addition, subtraction.
Right, there we go. So we're going to use that principle where we want the brackets first, right, to create another law called distributive law. So let me give you an example. Let's say that I gave you, so let's say Athzura, write some example. Athzura and Ludi have stickers. Let's see. Athzura has 4 stickers. Ludi has 3. The teacher, Mr. Thompson, gives each student an additional 4 stickers. What is the total amount of stickers? All right, this is very rarely see questions like this, but it's just an example to show you. So, what numbers are we working with? We have 4. What other number do we have?
3.
3.
4.
And another number 4. 4. Right? So, is there a relationship between any two numbers first?
4.
4 and it said 3, right? So it said first of all that you had Athzura having 4 and Ludi having 3. So essentially, you'd want to find the total amount of stickers that is right there right now before you put on the additional, correct?
Yes, sir.
So you would say that Athzura plus Ludi will give you the current total amount of stickers. So we're gonna say 4 plus 3, right? If the teacher gives them additional of 4 stickers, my bad, I should have put of 4. What are we doing? We're
multiplying.
Right, so we're gonna say 4 plus 3, right? It's gonna now be expanded to have 4 stickers on each. So after Drew is gonna get an additional 4, right? And Lud is gonna get an additional 4. So let's expand this using the distributive law to find the total amount of stickers. So using the distributive law, we can find the total amount. Right. So how would you have normally done it? You would have said 4. So Athzura got additional 4. So it would have been 4 plus 4, correct?
Yes, sir.
And Ludi was 3 and he got an additional 4. So it would have been 3 plus 4, right? The distributive law essentially cuts this, right? And essentially states that, well, we can find the quicker route to see the total amount by saying 4 multiplied by 4, right? Plus 3 multiplied by 4. So just expand. All right, there we go. So now we're going to say 4 times 4 is?
16.
16. Right? 3 times 4 is? 12. Okay? But that's wrong. And here's why. Because we didn't use the BODMAS rule. Yeah, see, I got you. You followed me right into oblivion. What is the BODMAS rule? What first do we need to do before we use multiplication? See? Multiplication. So what first do we need to do? Work
the brackets.
Right. So what is in the bracket? 4 plus 3. So that would be 7, right? So that would be 7 multiplied by 4. What's that answer now?
28.
28. So this is the total amount of stickers. Right? So this method of distributing a number by using the BODMAS rule essentially helps you to find longer additions quicker. Because beforehand, you don't have to say 3 plus 4 is such, then that means 4 plus 4 is such, and a lot of rigmarole, right? So when you use the distributive law now, it essentially just distributes the number correctly and allows you to find the number easier. Everybody understand?
Yes, sir.
Yes, sir.
All right, good. So now, we've covered the 3 main laws, the distributive, the associative, and commutative. But in next class, we're gonna go in depth with distributive and understand how does subtraction work. That's our next topic after you've done the activity for associative and commutative. How does subtraction work in distributive law? All right. So let me see how much time. So we're working well with time. We have a couple more minutes. So I want you to take this from me. Multiplication over over subtraction. Multiplication over subtraction. All right. So that's the topic that we're going into. But the general form, because remember, in every law, we made a general form. So we need to make a general form for distributive law. General form is essentially going to be same A plus B and C, right? But in this case, we're going to say A times, right, B plus C, it's going a little bit closer, right, is equal to, each number gets 4. So we're going to say A plus B times A plus C. So what is the common value that each Ath0 and Ludi share? So Ath0 is B and Ludi is C. What is the common value that they share? A.
A.
Right? And A was given to be the 4 stickers that each person would have gotten. So that's why you see that they share the same A, because that's the 4 stickers that each person should get. Understand?
Yes, sir.
All right. So this form of putting the number on each term, let's write this. The method of putting a number outside of a bracket inside is called expanding. All right, we're not talking about the universe expanding. We're talking about math. So we're saying that when you essentially show what is actually happening when you have just A bracket B plus C, that's expanding it by putting the A on the B and the A on the C. So this is another topic. Let me put it bracket expansion. Right. So we're gonna pause there for today, right? And then I'm gonna go through now what your task is. So we're gonna put a break right here. Let's put a to-do sign. This has to be done next class. It has to be the next class. But we've completed commutative law and associative law, so we can put a tick there and a tick here. Good.
Can you scroll down, sir?
Okay, let me scroll down. So what we're gonna go through next class is how does subtraction work and what is the process of using distributive law in subtraction. That's next class. Right? Okay. But the homework, right? First homework is that you're gonna get a true or false exercise.